Stirrups viewers, get ready for a crazy lesson today. It's going to be awesome.
Okay, my friends, let's get homework out from last time. And if you need a calculator, get that out or go grab one. And then let's also get Smurf Tree Forest paper out. So I believe... I believe we are on the page. Let's see. It is 1, back, front, back, front, back. Back, front, back, front, back. Starts with Unit 2 review. Oh, those are just the answers. Go to Unit 3. Go to Unit 3, if you don't mind. Okay. Unit 3 on Smurfville paper. Is there any you need? Wait, our little dance. Drew already came. Alright. Yeah, this is kind of Algebra 1, but Unit 3, number 1 through 7, any of those? Yeah. So actually, go back to Unit 2. I can do this. Like your stat edit? Yeah. Do it now. Plug it in. Anything on page that Unit 3? 1 and 4. All right. Math, graph, Cartesian. All right. Ready? Problem number 1. Y equals 2x plus 4. And x plus 2y equals 3. So that has a y-intercept of 4. Then up to right 1. Try and draw a straight line best you can. This one, cover method, so that's x equals 3. And y equals 3 halves, which is 1 1/2. So it looks like my solution is -1, 2. That's where they cross. And what other one you said? 4? Huh? Yep. All right. 4, they want us to do technique of our choice. Okay, so this is number 4. We have x equals y minus 5, and 3x plus 2y equals 3. I would personally use substitution on this, where I take that, plug it in there. So that's going to give me 3y minus 15 plus 2y equals 3. So that's going to be 5y, add 15 to bring it over. Are you kidding? That answer is that ugly? Dude! Okay. All right, so that's, if I add 15, I bring that over here. So I get y is equal to 18 over 5. Yuck.
Isn't that 3?
No, it's 3.6. All right, and then I can pull that in there. So I'm going to change. I'm going to go 18 fifths minus, that's going to be 25 over 5, so -7 fifths. Oh my gosh, that's nasty.
That's real nasty.
All right, flip the page on Unit 2. Hey, word problems, yay! 8, 9, 10, any questions there? Ooh, and it's one of those bounded region ones. Those are always so fun. I can tell you the bounded region ones on the test are either it'll say, hey, what looks like, the whole test is multiple choice. I don't know if you all knew that, which some people get really excited about, and then teachers really get excited about because
You don't got to grade it.
yeah, it's graded, it's already done. Yeah, you do it on Scantron. I won't even do it on Schoology for you. Dude, someone's calling.
Who?
I don't know.
Answer don't speak.
Declining it. Alright, any questions on 8, 9, or 10? 8, 9, or 10 on?
Yeah,
10? Okay. So we have this bounded region. Number 10, we have this bounded region. So we have like something like this, and something like that. And boy, I did pretty poorly with that. But that's shaded. That's 0, 30. And that one appears to be, maybe 5. Maybe 530. And then obviously we have the 0, 0. All right, so my vertices, we've listed our vertices. And then P equals, you're going to plug, you have 5x plus 3y. And C equals 2x plus y. And I don't think I have to work all these out, but these are all xy values. I'm competing with voices, and they're not the ones in my head anymore. I took my medication. All right, I'm going to take each of those xy values and plug them in. So if I plug this one in here, I'm going to get 90. If I plug it in here, I get 150 and 90. Bless you, it's 240. If I plug that one in, I get 200. I'll plug that one in, I get 0. So my max profit is 240. Okay, do the same thing with the cost. You're just plugging them in. It shouldn't be too much rhyme or reason or madness. Okay. And then number 11, I will not give you that on the test. You don't have to come up with the equation and the graph and find the feasible region. There will be a multiple choice. And the multiple choice, if you have basically 3 lines drawn, you better find 3 lines drawn on your page. Okay? So let's put that away for another day. And what kind of questions did we come across? I should do evens. Is that right? Okay. What kind of questions did we come across on the homework? Number 22.
Mr. Stirrup,
Yeah.
I have a question that's not a question on the homework, just multiplying two of the matrices together. Sometimes it has, like, you put in a multiplication sign at work, and sometimes it doesn't. You just have to put them next to each other.
If they're next to each other, I think the default on the calculator will multiply them without having a multiplication sign, I think.
Because sometimes having a multiplication sign, it doesn't split and it won't work.
Oh. So sometimes, yeah. I'm not sure what the default mode is on that. All right, which one we say? You had a question on 22, you said? 20? Okay. Problem number 20. We have negative 2 and 5. And then we have 3x and 2. And that's equal to negative 8. Okay. So let's just verify how this would even work. Okay, this is a 1 by 2 matrix here, agreed? And then this is a 2 by 1 matrix here. So my inside dimensions match. So I get a 1 by 1 answer. That works. Okay. So it's going to go this way times this way. So negative 2 times 3x plus 5 times 2 equals negative 8. That's the math that would take place. So you take the entire row times the entire column. It's like multiplying and then you sum up those terms, which we don't have that many. So I get negative 6x plus 10 equals negative 8. And then that's going to give me negative 6x. Mine equals negative 18. So x has to equal 3. Okay. Anything else off the homework? What? 24. Says a women's softball team needs 12 bats, 45 balls, 15 uniforms. The men's team needs 15 bats, 38 balls, 17 uniforms. The cost per bat is 21, per ball is 4, and per uniform 30. Make a 2 by 3 matrix representing the needs of both teams and a 3 by 1 matrix representing the cost of the equipment. Okay. Good call. Let's see. Number 23. So we have 24, you said, right? Right. So we have bats, balls, uniforms, and you have males and females, right? So this looks like we need 12 bats, 45. Oops. That's women, that's men. Meter. Maybe like that. 12, 4, and 15. And then for the males, it was 15, 38, 17. And then we have this matrix. This is the cost. So we have bats, balls, and uniforms as far as a cost goes. It told us that cost per bat's 21. Cost per ball is 4. And the cost per uniform is 30. Alright, so now I have to see if I have it set up in the appropriate order. So this is a 2x3. That works for me. And that is a 3x1. And then let's see, we're just gonna, it says, then multiply to find the cost per team. So when we do this, so because my inside dimensions are the same, we can do it. It's going to give me a 2x1 for an answer. When it gives me a 2x1 for the answer, one of the costs will be for the women's team. That will be the top one. And the bottom answer will be the cost for the men's team. You ready to do it? All right, 12, 4, 15. What was my matrix? 12, 45, 15? No, wait. 12 bats, 45 balls. 15 uniforms. And then for the guys, it was 15, 38, 17. Cool. And second quit. Got to make sure you do that. And second matrix under B. I'm going to make that. So I guess it did that. I don't know why I didn't make B that. Okay. Letter. This one will make our 2x1. And then it should be a 3x1, isn't it? I'm sorry. I am off today. And then how much did 21, 4, and what? 30. Alright, so it's going to be second matrix 2 times second matrix 3. Enter. So it looks like the women will cost $882 with all of that stuff, and the men will cost $977 with their stuff.
Question back to number 20.
20? Yeah.
When we're multiplying them together, remember yesterday when you turned the
Inverse?
on its side?
You're looking at 22?
20.
20. Yeah.
Yesterday you turned one of the problems on its side to get it to work.
No, that one works as it sits.
Okay.
Because it's a 1x2 and a 2x1. So you just go -2 times 3 plus 5 times 2 equals -8. And then solve it. We all good? Alright, so we had a curious class yesterday, and someone asked, how would I find the inverse of this matrix C by hand? Well, there's something called the identity matrix, which looks like this. So you have a diagonal from top left to bottom right of 1s. Everything else is a 0. Okay? If I do this, we don't have any more class time left, but I just want to show you how it's going to take place. What I want to happen is I want to manipulate my rows and columns by adding and multiplying rows and adding them to others. So I want to get a 1 here, which I have. So if I were to get that to be a 0, I'm going to multiply this entire row by -4. What do I do?
My brother's sweatshirt.
Okay, so if I have that, that means I can take my whole first row and add it to my second row, and that'll give me a 0 down in the second row. So then I'm going to take my first row and redivide it by -4. So it's going to take me back to this. If I add these two rows together now, then I'm going to get 0 here. I get a -3 here. I get a -6 here. -4 here, a 1, and a 0. Now the bottom row is this. So then I need to get a 0 here, so I'm going to multiply this whole row by -7. I'm going to rewrite this row. So I'm going to take my first row, divide everything back by 7, so I get 1, 2, 3, 1, 0, 0. My second row stays as is for right now. So I'm going to add these rows together, so I get a 0 here, I get a -6 here, I get a -13 here, -7 here, I get 0 and a 1. So now I have that whole first column being zeros. So then I want to make this right here a 1. So that means I'm going to divide this whole row by -3. Okay? So then what I would do is say, okay, I want to make that now a 0. So I'm going to multiply this whole row here by -2. -4, -8/3, -2, 0, 0, -6, -13, -7, 0, 1. Okay, so I'll add these rows together. So 0 plus 1 is 1. That's 0. That's -1. That's going to be -5/3. -2, 0. Divide this whole row back by -2, so it goes back to normal. 1, 0, 0, -6, -13, -7, 0, 1. Oh, we're doing well. Now I need to make this a 0, so I'm going to multiply this whole row by +6, add it to that row. And then I need to make that a 0, that a 0, and that a 1. But take a look how long this problem. So like this is my normal size slide. Look at this one. I'm not even halfway done.
Are you?
No. So fortunately, y'all have a calculator to hit x to the -1, which finds the inverse of the matrix. And then you have that really cool feature. You hit math fraction, enter, and it makes them all. Now the tough thing about doing this, this is like psycho math right here. This really is. But this is the math of how what they do with this is realize how big of a dimensional matrix can you make. Enormous. So what you do is you encrypt your data, and then what you do is you make the inverse, trying to find the inverse of that matrix like impossible to find. Because if you find the inverse of the matrix, then you unlock the password to get in. So I will tell you that a 3x6 matrix, where you're finding the inverse of the 3x3, would be a very soft software program. I would say that the CIA and the FBI, they probably use 100 by 100 matrices where each of your units are not whole numbers, they're fractions, they're decimals, they're irrational numbers, they're rational numbers, they're complex and imaginary numbers, and shoot, they might even be perverted enough to have equations as each term. That's how they lock security of banks, secret files, everything. That's the math we're doing. And so you try and take these math programs to try and break the encrypted code of these, And you see how long that one page is. I'm not even halfway done with that problem yet. So more than double this length here, and we'd get done if I didn't make a sign error. He's like, go find your sign error. Oh, shoot.
A single one.
Just one error can really change a whole lot of stuff. Right? Think about your password. Let's see, I have a 6-digit password on my phone. Can I get 5 of the 6 right? And it says, that's good enough.
Yeah.
I don't think so. It does that shaky thing. So, cool. Fun stuff. I'm sorry. I'm a geek like this. You know that. All right. So, do we feel comfortable with worksheet 7A and worksheet 7B? You feel comfortable with it? Something that we're okay with? Okay. I don't really have a lecture for today. The only thing I wanted to tell you about, and you're able to do it, is on worksheet 7C, it asks you to use Kramer's rule. And I'm not teaching you Kramer's rule. So like number 10's question looks like this. I think 4x minus 7y equals 19. X plus 2y equals 1. Okay. So just by looking at this problem, I could tell you that if I wanted to make this a matrice, I could do it one of 2 ways. I could make it this. Oops. Okay. Is that okay like that? Does everyone feel comfortable how I just generated that? I took the lead coefficients, and then my x and y became my 2 by 1. So we learned yesterday that we take the inverse of this, right? Take the inverse of this, and whatever that inverse is, you multiply it here, and that'll solve your x and y. Okay? There's another way I can write this. Can everyone feel comfortable with how I just wrote this one? This is the exact same problem.
It's just a different direction.
Yeah, so that's now a 2 by 3 matrix versus a 2 by 2, a 2 by 1, and a 2 by 1. Okay? Second best key on the calculator. Coming right up. Enter. Almost. All right. So,
Clear.
So let me off. Oops. There, here. Okay, here, like that. All right, I'm gonna go to second matrix, and I'm gonna go down. Actually, I'm gonna go over. I'm gonna go down to the letter F. Is that okay? And I have a 2 by 3 matrix C that's there. And my 2 by 3 matrix C is 4 and negative 7. 19. 4, 5. Negative 13. Okay? So do you feel comfortable that that's the same matrix I had on the last board? Okay. All right. Everyone ready? Yeah. All right. So second quit. Okay. This is life-saving, this one. All right. So I'm going to go back to second matrix. Still with me? I'm going to go to the math screen, so 1 over. And I'm going to arrow down to find RREF. RREF stands for row reduced echelon form. What row reduced echelon form means is to solve it. But they use fancy terms. So I'm going to do that. I'm going to hit enter. Now it's like, well, what do I want to do row reduced echelon form of? Oh, I want that one matrix. So I have to go back to the matrix. Number 6. Close the parentheses. It's important you close the parentheses on this a lot of times because sometimes it goofs up. You hit enter. You get that. You hit math, fraction, enter. So my answer to that problem is my x value is 1/12. My y value is negative 8/3.
Wait, but isn't the other answer still also correct?
Yeah, but I can give you an exact answer right there. And I would expect y'all to give me the exact answer because you all have a calculator and math, fraction, enter shouldn't be the hardest thing in the world to hit. Are there some decimals that we can't make fractions? Yeah, we call them irrational numbers. Does the calculator know what these are? Yes. So there's a certain decimal that you're going to get to that won't be able to find the fraction, but that's okay.
It's a calculator gets it. It's gonna be like, what the frack, man?
Yeah, it's going, dude. All right. So let's play with this one more time. So let's go on a little adventure. Okay, I'm gonna just talk. You're gonna enjoy this, I think. Okay, dimension. You with me on dimension? One dimension you learned in geometry or zero dimension is called a point. Agreed? It just marks someplace in space.
One dimension is a line.
One dimension is just a line. And the thing about a dimension is you can go backwards and forwards in that. So a zero dimension is not a dimension. Okay? A one dimension is a line. You can go backwards and forwards. Still with me? Second dimension is like a plane. So like the floor. I can go left, right, frontwards, backwards on, right? Third dimension is length, or like a plane and two planes intersecting each other, and a third plane. So think about like this room. We're in the third dimension. Fourth dimension, some people say, oh, it's time, and that's kind of correct, but you have to understand a dimension is something you can go backwards and forward in, and you can't know how to go backward in time. So time is actually a half dimension, which falls really nicely into chaos theory when you're talking about half dimensions. Okay? Scientifically, they have determined up to 9 dimensions that are fathomable in the scientific world. Okay, no, I can't tell you what they all are because I don't have them. They all deal in the subatomic world, so it's like a dimension of a dimension you're dealing with, which is amazing. But let's just we want to go to the 9th dimension. Still with me?
There.
All right. So let's say I'm going to go down and I'm going to edit letter number 1. Okay. So we're going to say, let's say we have a 9 by 10 matrix. Okay. This means we're in the 9th dimension. So think about lines in the 9th dimension. I have no idea what they look like. I have no idea how a 9th dimensional line would appear in the 3rd dimension. I don't know if it'd be curved or anything like that. But let's just start plugging values in. I'm just making up arbitrary values. You don't have to copy mine. So basically I'm putting in 90 numbers. How am I looking on my grid? I have no idea. Oh my gosh.
I'm doing that.
If you guys have breakfast to go get, go ahead and grab it. I'll be here a while. I'm just kidding. No, you're not. Oh good, I'm almost done. We're halfway there. Whoa, living on prayer. Stirrups doing math and I just don't care. Oh. I'm sorry.
You got like the
Things that go on in my head, they probably shouldn't always come out.
Nah, but it's a good song. But still more.
I have no idea. Done. Okay. Yay. All right. So, second quit. Second matrix. RREF. RREF of matrix 1. Let's see if it even exists. Hit enter. Boom. Nice. Math. Fraction.
Give
Fraction.
me like a lot of zeros.
Oh, yeah, look at that. Well, so this is your identity matrix.
Scroll up, scroll down.
Okay? Yeah, I think that's all on the screen. Wasn't it 1, 2, 3, 4, 5, 6, 7, 8, 9? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So all of those zeros, this means my x value is roughly 0.32, my y value is 0.94, my z value is 0.32, my w value 0.23, my a value, I mean, I don't know what the rest of these are, but that right there, if you were to do it by hand, I don't think you have enough time in a year to do it by hand. To guarantee you did it right, because one error, and with my luck, I'd make one error like on the very first day, and then I'd carry through that error through the rest of the problem. But that's 9D right there.
How long would it take to do 100 by 100?
I don't think you have enough time in your lifetime if you did it by hand. I really don't. I mean, so if I were to ever teach linear algebra in high school, I would probably give that 9 by 10 matrices, some 9 by 10, saying do it by hand, and I'll give you an A for the semester. And I will guarantee that there might not be any kid in that class would have enough time throughout the whole semester to do it. That's the kind of long drawn out. Now, of course, the calculator does it in a matter of a second. You know, it takes you longer to plug it in than the calculator does to compute it. It's kind of fun. I used to do an extra credit project where I said, if you write all the combinations of using all the letters of the alphabet in a series of 4, so you have A, and then A, B, C, D. And if your hand wrote it all the way out, I would. It was when I was doing a statistics class. I said I guarantee an A for the semester. And then I started making rules up saying, okay, look, you can't have the freshmen doing stuff. There was kids that were soliciting, hey, come here. You write A all the way to A or AZZZ. And then another kid, oh my gosh, it was horrible. But it comes out to like 676,000 combinations. It's over 2.4 million letters that you're writing.
I take it no one did it.
No. I had one girl who did it, and I can't figure out how she did it, but this funny thing was, when I was in Nevada, they had, if you missed 10 class periods, you automatically got an F. And she missed 11 periods, and she turns it in and missed 11 periods. I'm like, I can't give you an A. And she goes, yeah, but you said, I'm like, I can't overwrite the rules of the book. I mean, it's like, you gotta come to school.
But she still did it.
Well, I understand she did it. I still can't figure out how she did it. Probably by ditching that much school.
Just give her a B.
I understand. Give her a B. Not when the school automatically locks you out. As soon as you got that 10th absence, F goes right in on the semester grade.
Does that happen at Creek too?
No. Actually, and there was a lawsuit that made it illegal for us to do it,
Which is good.
which is fine. I mean, you know, people pass all kinds of rules about school.
So now I can do it whenever I want.
Yeah. Shoot, we can't even pass a thing that says, hey, let's figure out if kids have a singleton absence. You know, like, I know none of you ever miss if we have a test or quiz in here. I know that never happens. But there are other classes that happens with and other teachers. That never happens with my kids. I know that. All right, so worksheet 7C. Let's do the evens. And then you're going to do RREF rather than Kramer's rule.
Nice.
Okay?
I'm so hungry.
Yes. Oh, I didn't show a determinant? Oh, it's one more key. Okay, it has to be a square matrix, right? This is where you find the determinant. I'm sorry about that. It's under, so let me just go into matrix, and I'm just going to make this I'm going to edit one. Make this a 3 by 3. Okay, so maybe I'll put values in. I don't, just some random numbers. So if you quit out, you go second math on the determinant, or second matrix on the very top one is called the determinant. You want to take the determinant of what? It has to be a square matrice, so that 3 by 3 will work. The determinant is the value of it. So the determinant of one I just made up is it's a number of negative 238. That's it. Cool? Everyone happy?
And how do you do it by hand?
No, I don't.
No?
Don't.
Oh, so we don't have to do one.
Don't. Not by hand. Nothing by hand on this chapter. Some of the other classes I know they're trying to do by hand, and you guys were talking to the kids in those classes saying, Mr. Sturp's class isn't doing by hand. They're like, why aren't you doing it? I said, well, because you all said during the last meeting we're not doing anything by hand. We're doing it all on the calculator. Oh, I changed my mind. Well, that's your fault.
Makes it easier for us.
I'm just trying to show you the benefit of the calculator. Everyone good?